It's all about angles today. First, we're going to do a quick review of how we name angles. One way to name this angle over here is by its vertex point, so I could call this angle A. Every once in a while you'll have more than one angle at point A, so then you would want to use 3 letters that trace around that corner. I could go from C to A to B, or from B to A to C, so that would be 2 more ways that I could name that angle. C to A to B, or B to A to C. Why could I not call that angle ABC? The reason is if I go from A to B to C, I'd be talking about this corner right there. So the important part is to remember that that vertex point must be in the center if you're using 3 letters to name your angle. And one last way, eventually I'll get kind of lazy and I'll just start numbering angles. I could call that angle 4, for example. That doesn't mean it's 4 degrees, it's just a label for that particular opening right here. All right, if I wanted to measure that in degrees, then I would put a little m in front. So the measure of angle A. And then I could stick a protractor on there and maybe it equals 50 degrees. Now the only time you're going to use a protractor on your assignments or on quizzes and tests is if it says to use a protractor. Otherwise you should trust the measurements that they've labeled on the pictures. And here's a fun fact. If you ever find 2 angles that are congruent to each other, you can say angle A is congruent to angle P, for example. But if you're going to talk about their measurements, the measure of angle A and the measure of angle P, what symbol do you think you use? Since these are both numbers, the measures are numbers, we're going to use the equal sign. So another example of when we use the congruent symbol versus the equal symbol. The actual angles are congruent, but their measurements are equal to each other. To classify an angle means to put it into a category. And so all angles that are 90 degrees are called right angles. And the little symbol we use when we have a right angle is sort of that little box in the corner, right? So if this were angle A, I would say for a right angle, the measure of angle A has to equal 90 degrees. Next is obtuse angles. Obtuse angles are any angles that are bigger than 90 degrees, right? And actually, I'm going to draw it this way. The measure of angle A is bigger than 90 degrees. 90 degrees is smaller than any obtuse angle, but I'm also going to say that obtuse angles are smaller than 180 degrees. Someday when you get to more advanced math, you'll actually talk about angles that are bigger than 180 degrees, like doing a 360, right? All right, an acute angle. Acute angles are smaller than 90 degrees. So the measure of angle A would be less than 90 degrees. And just to be specific, I'm going to say that it would be bigger than 0 degrees. 0 would be on the small end, 90 would be on the big end is what that means. And then a straight angle, this one might be new to you. If your first ray is right there and your second ray is right there, the opening is right here. Technically, that's an angle. It's an angle with 2 rays with a common endpoint. They're opposite rays though, right? And what is the measure of that angle? 180 degrees. So sometimes you'll hear people saying that a straight line measures 180 degrees. What they mean is a straight angle measures 180 degrees. Are you ready for this one? We got our second postulate of the year. It's called the angle addition postulate. Here's the long version. It says if P is in the interior of angle RST, then the measure of angle RST is equal to the sum of the measure of angle RSP and the measure of angle PST. It's not actually as complicated as it sounds. Here's what it's saying. See how point P is on the interior of this big angle? That's the setup. What they're saying is that if you take the measurement of RSP, angle RSP, that's this one in here, plus the measurement of angle PST, this small one in here, those 2 measurements should add up to the measurement of the entire angle. So hopefully that's not too confusing. We could draw it a little more simply if we went like this. This is why I like to number angles sometimes. I'll call that angle 1 and angle 2. So I could say the measure of angle 1 plus the measure of angle 2 equals, and then I'd have to label these. Maybe call them A, B, C. Equals the measure of angle A, B, C. So the B can go in the center that time. So that's the angle addition postulate, and I'm just going to show you a little example here. I've got a little fuel gauge here, and the fuel level is pointing to that point L. Here's point empty, and there's point full. And we can see that this is a 92-degree angle, and this is a 28-degree angle. Do you suppose you could find the measure of angle EOF? EOF is the entire big angle. And if you understand the angle addition postulate, all you'd have to do is take the 92 plus the 28, and that would equal the measurement of that big, huge angle. So 120 degrees would be the measurement of EOF. This entire angle right here would measure 120 degrees. Everybody say it out loud. Angle addition postulate. Angle addition postulate. Excellent. And one more vocab word for the day. It's angle bisector. We talked about segment bisector the other day, and that had to do with sort of the midpoint of a segment, right? It was something that goes through the midpoint, cuts that segment into two congruent pieces. An angle bisector, exactly the same idea. It's a ray, or could be some other thing, that divides an angle into two congruent angles. So here I've got an angle X, Y, Z, and it says that ray YW bisects. So that's going to be a very important word. Do you see that? It says it bisects that big angle, which means that these two angles are the same. And again, to mark two angles the same, we can't really go tick, tick, so we go swoop, swoop. And I kind of have those offset on this in red right there. Swoop, swoop. Shows that those two are congruent. Okay, back to the problem. The measure of angle XYW, XYW, that's that top angle, is 18 degrees. And we're supposed to find the measure of angle XYZ, XYZ, which is this entire angle, right? So can you figure it out? How big is this angle down here? Did you say 18? How did you know that those had to match perfectly? Two reasons. You saw the swoop, swoop on the diagram, and you saw the word bisects, which means that that angle is cut into two congruent pieces. So who can tell me the measure of angle X, Y, Z then? The measure of angle X, Y, Z should equal the measure of angle XYW plus the measure of angle WYZ. And our final answer would be 36 degrees. Notice I didn't use a protractor. I'm using the diagram. Unless they tell me to use a protractor, I'm going to use the diagram. All right, that's what you need to know about angles.